Hey everyone, and welcome. Today we're going to dive into one of the biggest ideas in all of chemistry. We're going to figure out what makes every single thing around us, well, unique. We're talking about the physical and chemical properties of matter. So let's just start with a big question. How do we even identify a substance? I mean, think about it for a second. How do you know that a piece of wood isn't a piece of iron, or that water isn't milk? To tell them apart, we have to look at their special characteristics. And in science, we call those their properties. So here's our game plan for today. First, we'll cover the basics of what makes matter, well, matter. Then, we'll look for what I call surface clues. Those are the physical properties. After that, we're going to uncover matter's deeper identity by exploring its chemical properties. Then, get ready for the big showdown, physical versus chemical, head to head. And we'll wrap it all up with a core takeaway that'll make this all stick. Ready? Let's do this. All right, first up, before we can get into the two different types of properties, we really need to get a handle on what a property even is and why it's so incredibly important for identifying everything in the universe. It's actually pretty simple. The properties of matter are just the characteristics we use to identify a substance. Think of it like a fingerprint, but for stuff. Every single substance has its own unique set of properties that makes it what it is and nothing else. Now, all of these properties, they get sorted into two big buckets, physical properties and chemical properties. And let me tell you, understanding the difference between these two, that's the whole ballgame. It is a super important concept, especially for your science exams. So let's jump into that first bucket, physical properties. I like to think of these as surface clues. Why? Because they're all the things you can observe with your senses, what you can see or feel or measure without actually changing the substance itself. Okay, here comes the textbook definition, and you're going to want to remember this one for your tests. A physical property is a property that can be observed or measured without changing the substance. Now really pay attention to that last part. The absolute key is that the substance itself stays exactly the same. So what are we talking about here? Well, it's things like color, shape, how dense something is, its melting point, its boiling point, and even its hardness. Think about it. You can see that an apple is red, but just looking at its color doesn't change the apple into something new. The apple is still an apple. See? That's a physical property. Let's look at some real-life examples. We know that gold is yellow. That's a physical property. Wood is pretty light, another one. Iron is hard, and water melts into a liquid at 0 degrees Celsius. In every single one of these cases, the substance is still the same. Gold is still gold, wood is still wood, and H2O is still H2O. No new substance gets made. Okay, so we've got a handle on physical properties. Now, let's flip the coin and talk about chemical properties. If physical properties are the surface clues, then chemical properties are more like the deeper identity of a substance. It's all about how it reacts and actually changes into something completely new. And the formal definition for this one is, a chemical property is a property that's observed during a chemical reaction. This is huge. It means you can only see these properties in action when the substance is literally in the process of transforming into something else. So what does this look like in the real world? Well, think about things like rusting, or burning, or how reactive something is with other chemicals, or corrosion. All of these processes totally, fundamentally change the original material into something entirely different. And these chemical changes are happening all around us. When you burn paper, it turns into ash. You can't turn it back into paper, right? When milk goes sour, a chemical reaction has made something new and, well, pretty gross. And when a nail rusts, it's not just iron anymore. It's a new substance called iron oxide. The big idea here is that a new substance is always formed. All right, everyone, it is time for the main event, the physical versus chemical showdown. This direct comparison is going to be super helpful, especially when you're studying for your exams and you need to tell these two apart fast. Okay, this comparison is everything. Look, on the physical side, the substance does not change, but on the chemical side, a new substance is formed. You can easily observe physical properties like color or shape, but to see a chemical property like rusting, you need a chemical reaction to happen. So here's the most important question to ask yourself. Am I ending up with the same stuff I started with? If yes, it's physical. If no, it's chemical. Whew, okay, we have covered a lot, so let's boil it all down to the one single most important takeaway. This is the simplest way to remember the difference, I promise. And here it is, the ultimate rule of thumb. Physical equals same substance. You start with water, you end with water, even if you freeze it into ice or boil it into steam. Chemical equals new substance formed. You start with wood and you end up with ash and smoke. That right there, that's the fundamental difference. Lock that in. So, to leave you with a final thought, let's put this rule to the test. We know melting ice is a physical change because it's still H2O. So, what about cooking an egg? Is that a physical or a chemical change? Think about what you start with and what you end with. Can you ever get that liquid egg back? Keep asking questions about the world around you. If this helped you out today, please hit that like and subscribe button for more. Thanks for learning with us.